Yo, yo. Yo, how's it going? Thanks for coming through, if you did. Alright, so who's ready for some faceplant shit? I know I am. Okay, so let's just like get down to it because there's a lot of shit to cover. Oops, Zach, wrong time. Bro, you called right at 7. I'll call you back. It's all good. Okay, so everybody can hear everything all right and everything can see it. Okay, it's a patch. I have another library sitting on my hard drive. I haven't like linked it up though. Okay, so faceplant's super fucking sick. These are some like deep sounds I was using for a track I was just working on. So I just load one of these bad boys up. Okay, so faceplant is crazy. We talked about how serum works and all about how synthesizers work in general up until this point. Obviously, pretty simple UI. I have a whole thing laid out for you guys to kind of like digest this UI with. But just at a first glance, it's always blank, which is great. Just because I don't like to have things preset. When something says it's semi-modular or modular, it should be blank when you start it up. Similar to the way Absinthe is when you load it up. I kind of make a point in that in this little outline here. All right, so you guys can download this. Again, like if you want these course materials, you have to be a student, in quotes, air quotes, just so you can get access to it. Just so I'm not allowing all my shit just to be out there. Because this is, you know, again, my knowledge and stuff, and it would hurt a lot if someone decided to go and steal and sell this shit. So, okay, so anyways, definitely also check out that course catalog. There's 40 classes in there, and that was me mapping out my string of knowledge. You know, it's just all the shit I know. It's the best way for me to present it to people, just in like segments and stuff. Because if I mentor people, they're just like, hey, can I go to the finish line today? What's up, everybody? Thanks for coming through. Okay, so what does semi-modular really mean? When a synthesizer is semi-modular, that means that the internal parts can be reordered and substituted with any that's in its shell and pre-coded for the UI. Okay, so that means we cannot create our own modules, you know, from code inside of faceplant, but there is a ton of really optimized shit that's in there that is really great. So what does that mean? When we command click, hold down command and click, we can search for things we want, or we can load up one of the oscillators. So 4 oscillator types, not 4 oscillators total. So it's really just you know, almost unlimited. I've really, like, over the last couple days tried to break it. And off stream, it's been pretty hard. I would imagine on stream, it wouldn't be that hard. So I won't really put it to the test while I'm on stream. But definitely something for you to test. Like, how many analog oscillators can you just go and stack up until it just explodes? Or wavetable oscillators. So really the most confusing thing about faceplant is, well, this, like, what does all this stuff mean? How do I edit this? Just like serum. You can draw. There's a ton of little drop down stuff too. So we're going to be going over all this stuff next week, just because it's, again, more extensive, just like serum. So I want to make sure we have time just to go into that, and then talk about phase modulation as well. Because it is called phase plant, and that is the thing that is phasing. So you can do this type of modulation on every oscillator. And then another thing, just about semi-modular, like true semi-modular. I have another partially semi-modular synth called Largo by Waldorf, and it's really great. It has a full semi-modular matrix, but it doesn't have a semi-modular UI. So you can't replace the parts, but you can patch the parts into almost anything. So serum, that's definitely what I call quarter modular, where it has a matrix, just like Massive. You can reorder its effects like FM8 as well. But you do not have the capability of replacing oscillators, changing type of oscillators, reordering oscillators, changing signal flow. You do not have that option. So that is, I think I say at some point, that is just a glorified subtractive synth at that point. So it's a subtractive synth with a lot of modulation capabilities. And subtractive synths in general, if you've ever seen a hardware subtractive synth, they have preset, always routed modulation. And with serum, it just kind of takes that cap off and allows you to patch it to almost anything. I emphasize almost anything because having the limitation of not being able to patch the output of an oscillator into literally any parameter is a huge drawback to modular synthesis specifically, because FM on everything is one of the selling points for modular synthesis. Specifically when hardware is involved, any type of signal converted to voltage is now modulation. So that's really the thought process. In digital synthesis, you have to convert that into data. And I actually have that in the curriculum too on how to do that. But that's going to be 301. So going to be 301, how to build your own synth in Reactor, making hybrid synthesis happen, meaning sampling and analog, wavetable, anything else you want to combine together, similar to the way Omnisphere works or anything like that. So you can build all that stuff really easily from scratch. And as well as like spectral processing and stuff inside of Reactor. You just have to know how to access it. Okay, so we know that we can reorder stuff and that it's literally how we have the capability to modulate. But the main founding thing about true, pure semi-modular synthesis is changing the parts, taking out an oscillator, putting the oscillator in a different place, a different part of the chain, patching it somewhere else. Being limited to signal flow is a huge setback for like modular type of synthesis. So I would be able to get more, crazy patches out of phase plant than I would in serum, just because I have more patch points. And that's literally the thing. I'm really stoked on the new update for serum for sure. Being able to resample the output of an LFO is really tight actually. Honestly, that was a very small function I didn't think was very pertinent, because you can always drag an LFO into a wavetable. But now being able to print modulation in time and capture 2048 samples of that from its output is pretty cool. But still, you're limited to its signal flow. So until it has all this stuff, it's still not in the same category as phase plant. It literally has a wavetable oscillator in it, but it is not like serum. It is the thing that should expand your mind post-serum. If you can't understand serum, again, phase plant is going to be very hard to digest. Okay, so just kind of like stepping away from that little lecture, I guess. Why is phase plant different? Because of everything I just said. So you do have almost unlimited modulation, filters, effects, oscillators, signal flow. So you have all those different types of combinations you can do, meaning that when we're in here, Notice as at the bottom of every effects lane, we have a patch point. So this goes into lane 1, that goes into lane 2, that goes into lane 3, and this goes to the output. So I can go and duplicate this actual output here, send this to 3 points, and then send all 3 of these lanes to the master if I wanted to. So that would be a parallel output where this is series by default. For I am Done, I believe those are already back up. Oh, thanks. Bless you, Vera Sound. Bless you. Yeah, I'm like the Mother Teresa of like synths. Just kidding. All right, so kind of stepping back again, so we have unlimited routing, not meaning we can create any lane we want, but we can create any combination with these lanes, which is 3. That's a lot. It's a lot. So you can patch this shit into a lot of things. You can also modulate it pretty easily just by clicking this button. Now I can send the output of this oscillator back into itself at any of these modulation points. Crazy. So simple. Like, it doesn't have the same type of drag and drop interface, which in my opinion at first was a little bit, how does this work? But really when you get down to it, it takes like a whole step out of the way, which is clicking, dragging, and dropping. So now I just click and drag. So that's nice. And I can just, do something like that. And then see the effect in real time. Sick life, bruv. Feedback loops, yes. So that's exactly what I was just doing. And I was modulating its phase by creating a feedback loop. And we're going to talk about phase modulation in a little bit. That's also going to be a focus of next week. And if you check the outline, after next week, we're going to get into FM synthesis and talk about the actual theory behind it and how to create sidebands and predict sidebands. And you can do the same thing with phase modulation too. So phase modulation is a little bit more advanced, but it is definitely more gritty. It has more weight to it, in my opinion, just from a superficial kind of take on it. Okay, so I mapped out this really basic routing order. So what does this mean? This means that in order for me to create like a dual oscillator synth, I need to create multiple amps. So we talked about the components of a synth. If you don't understand what the components of a synth are, it's probably a good idea that you go and get familiar with those, because these are, again, going to be just about those functions. So when you know what those things do, then you can kind of execute them a little bit quicker. Same way where I developed a workflow in FazePlant here. Like, say if I wanted to create another module, all I have to do in any of these sections is click. If I want to create a module in between something, I hold down Command. And that allows me to add effects in between my wavetable oscillator and my amp, which is literally just the output. So that means I can add a distortion or a filter. I can also create another group. Or down here I create a group, and I have a separate group. So then I go and right click or command click. Make an analog oscillator. Say this is my sub oscillator. So now I need to send it to the output, because without an output, without a mixer or an amp, it doesn't go to the output. So how do I route this to the output? Say bypass sub to master, patch to master. So notice as you have all of these outputs here, so I can, again, add more outputs, sum them together. So see the signal flow right here. It's literally telling you how the signal is flowing. It's saying send analog oscillator parallel into both out 1 and out 2. How do we know that? We see one line, bam, and then crosses through that, bam. So this is literally to signify where this amp is flowing. So we have 2 different outputs for this now. So I can route it into the effects chain if I want, and I can route it to the master. Wow, dog? That shit's fucking dope, dude. Oh shit, dog. Like, you telling me like I can just do that shit whenever, dog? Yes, dude. That's like the stoner in me just being like, fuck, bro. Alright, so, you know, after you get your little group set up, you can filter it, add movement, add modulation. But you can also name it. So, OSC1. And then this will be my sub oscillator. Subs. You know, what's great about this is I can actually put a little like effects chain, mini effects chain onto my sub, which is distortion. Oh shit, you can name shit? Yeah, dog. I know. Alright, so that's pretty crazy. That is literally insane. If your mind's not like already thinking of like 50 different ways you can apply this shit, then I would say you don't understand yet. So, just to backtrack again, let's go back to a new patch. 0 things loaded up. So, I want to load up one thing first, a group. So the group, first group you make will automatically create an amp because it needs an amp and it's trying to coax you along the process of making a sound. It doesn't want you to be totally lost. It wants you to have unlimited capabilities. This is actually the most simplified complex synth I've ever seen. Like, seriously. Like, this should be way more approachable than almost every other modular synth. But it applies so many different modular techniques that it's honestly insane how good this sounds and the amount of shit that they have and how stable it runs. So that's just something just about Faceplant specifically. So we'll just route this to the output. Let's play it. Cool. Plays. Make this a bass. So I'm gonna scroll this down, click, drag, and scroll. I can change my voice engine right here. This allows me to change pitch bend, master tuning by semitones or synths. This is really cool if you're trying to do super woke music at 432 hertz. I'm just kidding. But like if you're trying to like record like samples that are the perfect length for like wavetable and stuff, having the sense control right here is really sick. Serum again does not have that. You have to go and tune them together. Okay, so a little tiny version of that exists on the analog oscillator or the oscillator itself. So we have a unison engine here, and we can see it multiply. And again, this is going to work similar to Serum in terms of its polyphony engine. And to Tesla, your question, is Faceplant more CPU intensive than Serum on average? No, actually. It's actually more stable. I think it's just the actual weight of the wavetable oscillators themselves. I think that Serum has a very high fidelity and a ton of different applications for its wavetable oscillator. Like, and for Serum itself, like resampling engine, like 5 different qualities for the output. So this is just more dialed in to be modular. And if anybody kind of knows kilohertz plugins in general, they're all 0 latency. And I highly recommend you go and get that $10 a month pack because you'll get all this shit. And multipass is going to be something that we go through as well. Multipass is pretty much this, except with 5 bands possible. And all these modulators. And all this MIDI you can send into it. And all these possibilities. It's sick. Okay, so that's another one that you're going to be able to understand and, you know, apply this shit to pretty much all of Kilohertz's stuff. One thing I really like about their plugins is that they're very simplified and they're very effective. You know, I really hate one knob plugins, like in general, like just because they trick producers into thinking that they're doing something that's controllable. I mean, like putting sausage fatter on things, it's fine, but you're really like distorting and limiting. And if you knew the pieces of that, you can make something more optimized by knowing those two pieces, which is saturation and limiting. So you wouldn't go and jump to one of those one knobs if you actually knew what you were doing in individual plugins. And also you'd be able to get your shit just as loud from a glue compressor as you would from Pro L2. Glue compressors are loud. Why? Why? Because they have no actual limiting. They're soft clipping too. They're actually digitally clipping. You're hitting 0. If you put glue compressor on your output and you do not have a ceiling, you are clipping your output. Literally digitally clipping. 0 does not exist in the digital world. Sorry. That's just cold hard fact. Anyways, it'll get your shit loud, but doesn't mean it's going to be, you know, master level quality kind of shit. Anyways, not to diverge myself anymore. All right, so we just talked about how to set up these oscillator groups and how to kind of like, you know, start your little signal flow and get something going. So I have a whole outline in here just on how to use this synth, and this is directly from their manual, which is online. You can access it there or probably on your computer too. So a lot of these pictures and wording are from there, copy and pasted, because this is pretty much what I do when I want to go and just really hone in on one part of a synth and really understand what's going on. So kind of want to have this just open, you know, so we can kind of like go back to kind of talk about it. But we did just kind of have an overview of the UI. So all this stuff of the UI should be pretty self-explanatory, meaning where's the browse button? Right there. How do you go through presets? Right there. It's all very, very uniform, so that shouldn't be new, you know. If anything, that should be the easiest thing for you to navigate in the synth when you load it up, is where's the presets, look for that folder icon, and you're good to go. Ultimately though, this class is so you don't rely on presets, so you can be a cool guy. Alright, so another thing to note, a lot of these presets have macros and stuff, and you're going to want to start to apply macros. In the 110 course, we're going to be applying those macros. You checked out the curriculum that I put up in the Discord. You'll see that I have pretty much 110 laid out, so we're covering every specific sound, you know, just like a general overview of those sounds, including all types of drum sounds. Single down kicks, snares, and top loops, hi-hats, percussion shit. And then 201 amplifies that by going into physical modeling, then applying that with physical modeling and granular synthesis and more complex forms of modular and additive synthesis. And also applying FM to physical modeling because I do all that shit. It's annoying. Stupid knowledge. Alright, so clicking the little keyboard icon in the status bar will reveal the screen keyboard. So if you're can't see it, 6 right now at the bottom. That's why I included this, just in case you were confused. So again, remember, if you want to add to this little snap-in lane, you got to hold down command. Whoopsie. Hold down command, and you can just inject something in between it. And then, you know, just really just go all out. Do not like limit yourself. Try everything. Just drop everything in there. Throw it all at the wall. That's the best way to get your feet wet in any situation, especially when it comes to art and with a job. You just got to jump right into it, man. Can't be holding back. All right, so yeah, if anybody's confused on, any of this stuff, like how to load in stuff, where is MIDI, MIDI you shouldn't have to worry about. We're going to worry about how to filter that MIDI, how to send keyboard tracking, how to send velocity modulation, all that stuff. But those are the things that should be ready to go by default. So again, if you're confused on setting this up, let me know. We're not actually going to go too deep into preset creation yet until we go into the next section, because when you do create presets, there's a bunch of different options and almost what are presets, bro? Yeah, so there's like a ton of different options when like meta tagging your presets to like actually put your name on them, give them like dates and all this other stuff, and just like kind of like guarding your presets and shit. That's how I was able to like pick out presets of mine inside of cymatics patches and packs. I was like, oh shit, you didn't erase that, dummy. Yeah, calling you out. Fuck you, cymatics. Anyways, next. All right, so generator area. So this is what we just talked about. How to load in shit. How to get it working. So remember, command drop. So I'm just going to keep on reminding you command, because that's literally the command to drop shit in almost everywhere in FacePlant, which is dope because that's very intuitive, having one button to rule them all just inside of a small environment inside of the synth. I don't want all these, different key commands for doing all that stuff. So again, control or command. So control is for Windows. So I definitely perused this whole thing looking for some kind of limitations, and looks like 32 is the case. But I've tried to push it, past like 20, and honestly, I don't even need that much, really. Mainly because each one of these oscillators gives me unison, 8 voices of unison. So you have a ton of different flexibility. 32 modules, though, for when you're talking about oscillators, is pretty unlimited, though. So, yeah. Yeah, I'm just talking mad shit about cymatics. I'm sorry, y'all. My bad. Alright, so the generator modules are the ones that actually produce sound in FacePlant. There are 4 kinds. Blah, 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 blah. So we already talked about those. Analog, wavetable, noise, and then sampler. So sampler, just to look at all these different UIs here. So this is all the stuff that can go in your generator area, meaning distortions, filters, and a cool little like spectrum readout of your waveform or an oscilloscope that actively updates the way your sample looks based on the modulation going into it. That's really awesome. Gives you a very, very specific knowledge and information about what you're doing to your sound. And also note about this really crazy setup these guys got here. So what does this mean? We see this line here. It's hitting plus, 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 and then into the filter. So actually, that's a question for the chat. What does this mean? So I'm sending, or I'm not sending, I'm not me personally, but these oscillators, there's 4 of them, and they're all going into one filter. Mirror tip. So summing up to the outputs, summing. So summing is when parallel things sum into one cup, and the cup is the filter. So when we talk about, let me just zoom out here. When we talk about like mixing and stuff, that's super important. Just on how things sum together. So say if you were summing all of these oscillators together, do you have control of how loud each one of them are? No, because you need an amp. So amp in between each one of these stages can create a little bit more control over how to mix these things together. But also you have a little mixer module. So let's actually jump back into here. So we have all these different modules to kind of send signal to the lanes here. I want to make it just really clear on how this all works so you guys aren't, lost and just trying to get into the lanes here before we jump into modulation. So I have more than one oscillator now. I'm going to create more. Analog. So again, summing. And create another one. Let's create a noise. Now let's make a sampler. Kind of like that picture. So they're all summing to the output now. Ah! Loud. Alright, so I'm going to now mix these. So I can aux send this. I can send this out. Send this to a different point. So I can route this to somewhere else. This is allowing me to break this connection and send this modulation signal somewhere. So that is not what we want to mix audio. Want the mixer? So the mixer is literally going to reduce the amount of sawtooth now going into this chain. So how would we want to go and pretty much get all this stuff to sum together? Because now if I route another mixer here, this is now mixing. Let's actually drag this. So it's mixing the summation of these two. So I can mix these two together, which is the sampler. Let's get a little sample in here. And the analog oscillator. One thing I really like doing is being able to control the frequency range. So if I did want to do that, Jesus, I can just add a bunch of different stages of filtering in here. Whoops. Okay, so I shouldn't get rid of this noise. So again, let's step back here because I loaded up a bunch of stuff. When I'm sending stuff like this in line, which means in series, to this output, if I want to get my own oscillator or a separate oscillator that has its own output, its own modulation and stuff, that's when you want to go and break it out, and put it in its own group. So first step with that is create group first, and then create an oscillator. And then obviously got to create an output. All right, so now if I wanted to route these parallel, because now these two groups are summing to lane 1. So every single time you split out a signal and send it into one cup, you're summing. One cup being one output. Just best way to visualize it for me personally. All right, so how would I want to send this parallel? Right here. Lane 2, lane 1. Now both of my oscillators are running parallel to the master if I set it to that. So say if I wanted to run these two oscillators to their own lane. So now I send it to lane 3 because what I want to do is send them both to their own lane, then sum them into another, say, filter or something. Or processing, whatever you want. Okay, so why would you want to sum something, to Mary's question? For mixing purposes. So this is, where it goes into like sound design and mixing, fine tuning the sound to taste. Especially when we talked about the harmonic series and how that really affects the way you sound design. So say if you were going to harmonize something, so I'm going to harmonize this guy, going to pitch it up an octave and a fifth. So that's 19 semitones. So say if I wanted to just add this harmonic content to the frequency spectrum, now I can go and like high pass this here, say in the middle of its chain. take out the fundamental. Sum them together. I'm summing them together in lane 3 right now, so let's just go right here. Just gives me another level of control and blending when it comes to multiple sound sources. So summing literally is always happening at all points whenever you're listening to music anywhere. Summing is always having an effect. So summing engines, we talked about this, I believe, day 1 of like sampling class on bit depth and what sample rate means. But your summing engine literally is your final cup. So it's, 32-bit float, 64-bit float, whatever that is for your DAW, which means how it affects the signal whenever a signal's turned down. So if you had a bad summing engine, if you turn down your master, you lose bit depth. So 0, you get 24 bits, but if you pull down by 12 dB, you lose about 6 bits. Yes, so Tibetan group equals cup. Group equals small cup. So a bunch of cups and cups. So that's what a DAW is. And it's, kind of like core, element of what it is. It's a huge summing engine, summing all these tracks together to one output. So mixing affects all that. How the frequencies clash together, how you fit frequencies in together. So being able to do this just within the generator section is pretty crazy, especially with the amount of, filtering I can do and different effects and possible, groupings of different sounds. So I can, kind of layer it with a bunch of interharmonic stuff, maybe even put something up here way at the top. And then let's get another filter in here. Low passes, create a low band pass. Then maybe modulate something on that. That's also due here. So phase modulation, when we talk about phase modulation here, it's going to be FM. Okay, so a lot of different combinations you can do in here. All good, Galva. You are late. So yes, to everybody saying cup things, yes. And to Tesla, cup does equal bus. So anytime you send any signal out and it goes to one output, finishes, gets combined. The frequency range gets combined into 2 channels, always. Unless you are summing to a 5.1 mix, in which case you have 6 cups. You have 2 cups, 1 cup if it's mono. So you need to fit all your frequencies within 2 channels, sum them together. How does that work? A lot of things pertaining to phase also align with the harmonic series and music theory. So that's why we talked in the processing class about how the harmonic series affects EQ, mixing in key, and understanding how to tune drums, and the first step in finding the pitch of your sound if you don't really know the pitch. Because if I do something like this where I'm making a really dissonant sound like this, it's really hard to find the pitch. You know, if I want to be very rhythm about it, I'll just go and drop a sub under it, call it a day. But sometimes I like to actually tune my stuff to have this kind of relationship with my actual oscillator. Okay, so I'm gonna take a step back here, and now after we just talked about how the summing engine works and how to kind of set up different I guess routes in here, let's kind of like talk a little bit more specifically about now the oscillator. So we're going to go into the oscillator, and then we're going to go into modulation. Then we're going to make some patches. So that's the agenda. Okay, so the oscillator. So there's a bunch of different things you can do on this. Should be a little level generator there. Right there. But then also right here. So we can see that directly affects our oscillator and our oscillation itself. So semitone cents, 100 cents in one semitone. Then we have, I believe, up to 60. Yeah, 60. So 60 semitones, which I believe is about 5 octaves. Yeah. Okay, so 5 octaves of range. And then we have a harmonic shift. Oscillator as a multiplier of the fundamental frequency. And this is really important if we're going to be using this as an FM, or in this case a PM synth, which is phase modulation, not frequency modulation. Very similar, not the same. Why? Because this is what phase modulation does. I even define it a little bit more like sync modulation, because it's moving the start position of that waveform very rapidly, and that changes the length and pitch of the sound. So we'll go in more depth about that next week, just so we don't get too sidetracked on that. There's a lot of stuff that goes into it. But just for now, you know, say if you were making FM sounds, harmonic is the one you want to go to if you're going to go and repitch stuff, trying to be specific with its sidebands, you know, if you don't know those intervals in semitones, because literally just converting semitones into ratio. Okay, so remember what ratio means though. So we're talking about ratios again, fractions. So what is a ratio in terms of the harmonic ratio? 4. So corresponds to the relative pitch increase of 2 octaves, just like we've already covered. So we should know that 4 is plus 2 octaves. So again though, a ratio of 4, we talked about this in the wavetable class on how to design wavetables by hand and draw the waveform, how to predict the actual harmonic series and like calculate that. And so one window, so above 1 pretty much, it would be 4 above 1 if we're talking about a fraction. So 2 octaves above your fundamental will have 4 cycles in one window. So this is talking about really just this guy right here, or these two. So this should multiply it. I wish it, you know, fine-tuned around that, but, you know, if you did want it to be perfectly on phase, you could drag the start position like that. So it'll multiply it. So that's really cool. Doesn't go that high though. I mean, 70 in the harmonic series is high, but it is not an infinite scale. So when we are sending in modulation to make FM or other things like that, if we patch it into shift or into harmonic, it will give us more of a vibrato effect than an actual FM effect, just because of the scaling. And the scaling really affects FM sounds. And we haven't talked about how to convert data into an FM type of data stream, but that really affects it. It's a totally different scale. We're talking about dB and frequency modulation, just in terms of DSP. Okay, so now shift. Kind of like harmonic series, except now it's literally offsetting the frequency of this, still key scaled, but now it's being offset by a certain amount of hertz. So again, if you're trying to make like 4032 woke as fuck sounds, you can just tune it down by, I think it's like 8 hertz or something like that. Okay, so yeah, that's kind of like it for this little section here. I don't think we really need to talk about anything else there. Really self-explanatory. I want to kind of open up these other things here just so we can see all of them. All right, so notice that we have all the same functions pretty much on all of these oscillators, meaning level control, semitone, harmonic shift, and shift by frequency, phase modulation, phase start time, and then phase randomness. Okay, so we have all that for all of our oscillators. That means we can use phase modulation for samples. Fuck yeah. I love that. So that means we can record an analog sound, put it directly in phase pants. Phase pants. Phase pants. Put it in phase pant and modulate it with FM. Kind of like you would in Ableton's sampler. But now you can just do this in any DAW. So that's cool. Okay, so we have our noise engine here. So we have random kind of like peak values. Then we have random step values. Changing the semitones. On this one, changes those values, all the frequency values. And I believe stable will pretty much have the same exact start time. And that's kind of what it says at the bottom left corner there. Selects between having the same noise sequence for each note, stable, or a different one each time, random. So, same noise sequence, I think what they mean really is start position. And more than likely that is the case, because creating truly random stuff in a digital environment is near impossible. So it is not truly random. There's a lot of possibilities, seemingly random. But then starting at a random spot, it's a little bit more random. So we have random peak values, linear, random step values. And then we have, I guess, random curve values. It's like a random sine wave value. And again, we can make this more random by sending modulation. And so if I want to get an oscillator to modulate this, click the little plus button right here, click here and drag. So that'll give me some modulation on this randomized signal. Or vice versa. I can send the randomized signal onto the actual analog's pitch. But since this is in the group, this noise oscillator will be sent. So say if I wanted to use this as a mod oscillator, as in an oscillator to modulate my other oscillator, I would want to go and put this in its own group, just so I can, control it a little bit better. Just working a little bit more in phase plant, I've realized that's actually a very crucial part of the workflow, is being able to recognize when to drag these guys into their own group. Because now this is not going to any output, because I don't have it patched. It's going to require me to at least patch one oscillator to the output. But stuff like this, I don't need to have routed. Same thing with a wavetable oscillator or something else like that. So a lot of the really crazy sounds I've made with phase plant have been like from basic analog waveforms using not so basic wavetable modulators. So kind of like doing a FM4 with wavetables. And that's fun for me. All right, so I just really like the way this is all set up. It's really clean. It's It's really consistent, and that's huge. All right, so now onto the sampler. So we have a couple more things on the right here that we didn't touch on yet. But we're going to start just on the root note here. So this is going to be the bass pitch that the sample is recorded at. So the original pitch of the sample So can that be saved into the oscillator or into the sample? Yes. So once you go and load a sample in here, then you can change the root note and we'll find, or it will save that information for next time. So this is really cool, especially again for recording analog stuff and dropping it in here, or just doing the similar process you would with like a resampled bass inside of a sampler, or say granulator 2 or something like that. So again, root note allows me to shift, and here's the craziest thing. Whoa! It actually lines up your root note based off of your frequency length, so that's really insane. Allows you to do it by cent values too. Exactly. Testosu's plant. Testosu's plant. Testosu's statement. Yes. Okay, so just to kind of like finish off what we're talking about here, we have a couple different loop functions. So this is off mode, plays through once, does not loop. Infinite, loops front to back. Start position can set right here, length right there, and then sample start you can modulate like this. So all of these things. So start position, this also is talking about phase relationship. So again, back to the phasing of phase plant. It also locks the phase of samples. So you can do sustain mode, so that loops up to a point and then kind of loops forward, pretty much. Forward and jumps. Infinite is kind of like a stuck mode, doesn't stop looping. Ping pong goes forward and back, whereas reverse starts from the end and goes to the beginning. Crossfade adds a crossfade in between the start and end position. It's actually Alright, there we go. So I move this start position here, gives me a little bit better of a phase. I'm going to take this, try modulating some of this phase. Just instant Reese's with this thing. Just all day Reese's. Okay, so one thing we don't really have control of in our sampler is unisono or unison. So if we do want to go and create unison on samplers, we can add more samplers, or we can add unison to the output here. If you want it to be summing as opposed to detuning, turn down the detune all the way. Now you can mix those unison voices with the blend knob. Okay. Okay, so that's a lot about the sampler here. Again, root note, which note it is starting on. We can see this really cool readout to kind of tell us our wavelength, and it will line up to our root note. A lot of these preset sounds are recorded correctly. So when you record stuff for a sampler, you should be recording it at some type of C note, meaning a mono sampler without more than one sample. So you really should do it to some type of middle C. And I personally always do it around the octave range in which I'm going to do it or use it. Sometimes I'll take a lead, pitch it down, see what I can do with it. Which honestly is really cool, especially if you're going to slow it down a lot and then add modulation to it, meaning FM or something like that. Okay, so these are really cool. Again, you should definitely like go record some analog synths or something. You can rent them for a weekend or whatever, or maybe not right now, but yeah, or do stuff in like VCV rack or whatever. Okay, so ton of different stuff to work with in that. Okay, let's reset this. Okay, so let's talk about the wavetable oscillator. So we're going to go deeper into this next week, but just to kind of start, so frame here is talking about where the wavetable is. You can also click and drag in here. This readout is similar to the wavetable in Ableton. Similar. But it is crossfading. It is somewhat spectrally blending. It is not as deep as serums go. So that's something to know. So in here though, we can draw partials. We can draw the waveform. So there's a ton of stuff we can do with this. And also note that this goes up to 1000, I think 1024 or 1028. No, I think it's 1024. I think it's just double 512. So that's a lot of stuff you can do. So we're going to go deeper into that just so we don't get too sidetracked on this. But yeah, just to kind of like step back again, we have all these wavetables built in here. This is a newer synth, so these sound really, really good in terms of just like preset wavetables. I also really like this readout. I'm sure you are also digging it. The way you can just see the entire wavetable. It's really clean. Let's turn this guy off. So that sounds pretty nasty. Okay, so all that's pretty cool. I can also run phase modulation, all that stuff, use it as a modulator, anything you want. Add unisono voices. Yeah, I totally agree with you, Louis Vuitton. They are super fire. These are really, really good wavetables. And they sound good too. They're not as biting and brittle as the original Serum ones. And I think that's just a result of the way it's spectrally processing a lot of stuff. Having a crossfade is really, really natural, I guess, because it is the literal sample and hold style of wavetable synthesis. Whereas spectral blending is adding another layer to that. Okay, so it's a lot of really cool stuff you can do with that. Just load it up a little distortion here. There's a bunch of little curves that you can load in. But yeah, this is just for mono oscillator. detuned it a little bit. Band limit is going to reduce the harmonic range. So it applies a very sharp low-pass filter to the waveform. Can be used to reduce noise during heavy FM modulations. So they're just giving you a suggestion, you know, like more higher harmonics, the crazier your FM modulation is going to be, or the more unpredictable your sidebands will be. Personally, I like to have a high band limit on when I do like really wonky shit. Like it's really good for that. But if you're doing like some more like deep wubby kind of shit, this can be a good thing to kind of pull back. All right, so now let's get this kind of like working and modulated. Gonna get good and modulated today. Whew, I am getting so modulated tonight. All right, so gonna just set up a filter here. So I want to make a filter envelope. So I got this basic envelope here. Again, we can send the output to any of these guys. So output of out is the output of the summing engine. It's not exactly the output of the envelope. If I go and create an envelope, then that will kind of give me the same modulation here because it's descending in amplitude. So can't really use our amp envelope as our envelope here. So we want to go down to our bottom section here. So click on that, right click, however, envelope. So we have this little meter here, and this is our amount. Top right corner, we have this little drop down button. It's kind of hidden. And this is for our direction on modulation. It's default to unipolar. You can set it to bipolar, which starts 0 in the middle, goes up and down. So that means 0, up, down. Right at the center line here. Or we can go inverted, which inverts the modulation. Okay, so I want to go unipolar for now. Then I just want to send the output of the envelope onto the filter cutoff. So every single red cross hair, red cross plus sign, is a patch point. So you can modulate anything that has this. So I want to do cutoff. So again, talking about modulation, percentage is always a percentage from the resting point. So I want to make it stab. I can bend to the line like that. Okay, so cool, filter envelope, dope. Also something to note about these filters is that they're somewhat basic. I wouldn't say they're that basic. You can sum a bunch of them together. So if I had a low pass filter like this, or say if I wanted to make like a growl kind of sound or something. This is now going a little bit deeper into how filters work. Or like if you're going to be making like a high peak filter or whatever, like you would inside of Serum with Serum's filtering. Yo, what's up, Vince? Okay, so again, if you're going to go and create this type of filter, which is a high pass plus a peak filter, then you want to go and sum your signal through that. So you want to create one peak point, another peak point here, add some gain. And turn down this modulation a little bit. Probably going to add a sub oscillator too. So on this one, I want it to go down while this one's going up. So I can give it a negative value. So we don't actually have to invert stuff. Inverting is to affect all modulation at once. Look at mom, I do a Skrillex. Okay, so now I'm summing these two filters together using one filter envelope. So it's exactly what I would do with a high pass peak filter inside of Serum. So it's, you know, really useful for that. You know, because like a lot of those filters in there, or just in any filter really, are just the basic filter types. They just give you a lot of options on how to combine those. Because you don't have the option to use more than 2 filters inside of Serum. So 34 modules, it's a lot. I'm only using 4 so far. So that means 30 more. 30 more in here. Just like, think about that. Okay, so it's a ton of shit. Just made a basic growl. Switch my content in here. I can sum together a couple different oscillators as well. Again, command, drop if I want to go and add an oscillator. So I'm going to go and get something that's a little bit more growly like say like a growl. Get oof. Now I'm going to add this modulation onto my frames. So now this is modulating my wavetable. Oh, oof, oof. Oof is right. I don't like that one. Let's do Twitter. What the fuck? Totally Twitter. We're doing lots of Skrillexes today. I just did 2 Skrillexes. Okay, so, you know, what I would do next would be add a sub oscillator. So I'd want an amp output, and I think I'd want a distortion, and I'd probably want a filter too. So that's how quick you should be like loading up your shit inside of FacePlan. He was like, I want this, and this too, also that, and maybe this too. All right, sure. Like seriously, to what Cam Gresham just said. Yes, that's literally what you can do with 5 modules inside of FacePlant with 0 processing still. I have 0 processing. So that's like, you know, it's really good. I haven't even used like its official filter yet. Yeah. Okay, so a ton of shit you can do with this. Why it's literally like my favorite synth right now. And it has been literally for like months. Sorry, I've been hiding that. I've been using this like most of my new shit. But also I use mostly VCV rack too, because I just like that workflow. So like sometimes I'll use my Serum shit, which I like my Serum patches. And then I'll go to FacePlant if I really just want to explore something new, you know, because I can find a ton of new sounds in here, especially for like any genre of EDM, especially for like any sound I ever want to just think of. It's like Serum is one of those multi-tools, kind of like Massive, where you can use it for literally any sound, just like wavetable and synthesis in general. This one just has so many more functionalities. Okay, so again, we've only used 1 modulator here, and I'm just using envelope. So let's kind of check out what else is going on in here. So we got LFO. So we have our basic LFO here, sine wave. I can go into my waveform editor and edit that LFO. Just like Serum, except we don't have modulation for these points yet. Maybe one day. Doesn't seem like it's too hard to do. I think Serum better watch out. FacePlant's still coming for it. shit ain't stop. Okay, so really simple controls in here. Find draw tool allows you to draw it by fine amounts, not locking to a grid. Click and point and drag, locks it to a grid. You can use this magnetic tool. This is kind of interesting because it kind of locks everything together. You can highlight all these points, edit, delete, file, save, new, select all points, delete all, create point, make new point, make sine wave, or choose a preset. So these again are very simple. These wubs are a little bit too crazy. I don't know what they were thinking. Some of these are cool, like the triplets one, I was able to use that. But the rest of these, I'm really confused on what they really want you to do. It's like one-shot kind of stuff for like one-shot webs. It's really hard to use these in like normal setting. These quantized 8s can be used as arpeggiators though. So let's put that into practice really quick. So we're just going to play an LFO now. And I'm going to sync this. Let's go to 1/16. So now stepping back, what does this mean? This subdivides. So if it's 16/16, then that should be one full bar. And we see this little guy now popping around, doing the jig. So retrigger means that's going to retrigger when I hit the note. One shot means it plays once and ends, does not loop. So I want to go and sync this now to something that's going to be kind of like fine-tuned for this. So let's go to our semitones here. Hold down Control on Mac or Alt to get fine amounts, which is locking to whole numbers. I'm also going to do it to this guy too. Let's go 12. And I hope I just, helped you on that. Like I was really just like, when I first started using this synth, I was like, how the fuck do you get anything to lock to a value? Sick, bruv. So, making some acid now. Yeah, literally. This is how you make polyrhythm. This is the polyrhythm patch. Okay, so kind of interesting. You can do a lot of stuff with that. Again, universal knowledge with that. You can turn any LFO that has a quantized step sequencer like that into an arpeggiator. Okay, so now let's check out something else in here. We got randomize. This also can be sunk. This is really cool as an arpeggiator. It's because we have so much control over pretty much every step here. So now this actually is worth, each step is worth one value. So again, let's map this stuff really quick. Let's go all the way up to 1 million. just to blow it up. Just kidding. I'm going to keep it in tune. Somewhat in tune. I keep on going back to the modulator to drag and drop it. You know, that's something I just got to get over. That is a limitation I just got to get over. Okay, so I'm having it kind of like drag around really slow, smooth. Chaos is going to give us a little bit of randomize. Adjust how much each random value depends on the one before it. So if I turn this down all the way, then it limits that randomization range. So I really like doing this when I'm doing like sound design stuff. I'll just slow it down a lot. Maybe add reverb, processing, a bunch of other stuff in order to like create some kind of random kind of like transformer sound or something. I could also change the polarity of this as well. By default, it should be bipolar. Okay, so that was weird. Cool stuff. All right, so now the final couple things in here. The utilities we're not going to go too deep on right now because I want to bring that in with complex modulation and stuff. But the MIDI note and velocity are kind of crucial. This note scaler is actually really crucial. Just if you want to go and add key tracking to anything, that includes filters. So if you want to add filter key tracking, you have to go give it a note value of 100%. So that's not something that's by default on your stuff. So you do have to go and route that by hand. So that's probably the most crucial one that I feel like you would be using more, you know, commonly. If you're making drums, maybe you want to use more velocity stuff, or if you're making leads and pads like that, I add a lot of velocity to pads, chords, and leads. I'll add velocity to modulation or to actual volume. When I'm talking about chords, I'm adding velocity to filter and to volume. So then at higher values or higher notes, because the voice engine creates an individual oscillator for every single note that I play, I can go and literally mix and filter one note using velocity just in the piano roll. So that's the thought process with that, on when to use velocity inside of a synthesis setting for a patch that's not a drum. We're going to talk about that more. But yeah, so like that's kind of it here. So let's talk a little bit about these. These are constants. So the constants Like this is probably the craziest one. So when I was talking about like how to convert info or data, how to step it up, how to step up data, so you can do FM signals. So like if we were going to do an FM signal in reactor, you wouldn't be able to send an amplitude signal of 0 to 100 in specifically a reactor because it needs to be multiplied by 1,000, or in that case it needs to be multiplied by about 500. So you need to set the value up to 5,000 on the parameter or the knob in order for it to actually give you FM signal. So that means you can go and multiply these harmonic shifters using this and create constant values that allow you to crossfade in between a couple different things. So you can input a couple different values and have them sidechain each other or have them multiply each other. So it's really cool. Again, way more complex than I want to talk about right now because I feel like that will be lost on you at this moment. So what I'm going to do is we're going to go and talk about the effects chain. So let's go back. Let's actually make a little chord. Oh. Okay, so I'm going to send this into lane 1. And really we only need to talk about one lane because they all have the same stuff. Yeah, let's kind of go one by one and just talk about them. So we got 3-band EQ. Obviously. Crossover right here. Then we have the shift, 2 shelf filters, and 1 bell curve. 3-band EQ, basic. Basic. Alright, so now we have filter. So we already talked about this in here. Basic filter types, slope, multiplier. And I believe we can modulate that as well. Yeah. Oh, no, we can't. That's just for the gain. So we cannot modulate this. But we can modulate all these guys. So shelf filter, yeah, band pass, high pass, notch again. Should go down to infinity, and it does. And then bell curves. So those are all your basic ones. Again, if you want to make multi-filters, you might want to patch them in parallel. So that's multiple outputs from one oscillator. So now we have pitch shifter. This is pretty cool. This is a granular device. Okay, so this literally takes all the frequency information and shifts it by hard semitones or cent values. So correlate down here, let's actually get that hard definition on the bottom left. So switch between the classic and auto correlating algorithm. So auto correlate meaning snap those grains to the right value like an auto tuner, or jitter around and kind of be there. So grain size, definitely more important when you have smaller or bigger information coming through it. So if you wanted to do something that's like a percussive sound or something, you might want to do a higher grain size. But if you wanted to make it sound like metallic or something, smaller grain size. And then for a polyphonic sound, meaning playing more than one note, do you want to have a small grain size because there's fast, high frequencies happening. Okay, so it is polyphonic too. So it does find all the notes. It is like texture inside of your warping algorithm. It's really cool. You have a little preset engine for all these guys, randomizer. Roll the dice. Just want to get a bear chord in there. Okay, so bit crush. Bit crush. It's crushing the bits. Sample rate reduction. Okay, so we have quantize, which this is going to be the kind of the step value of our waveform. Bits also correlate directly to that. So more quantize, the more harsh the sound is going to be. Bits, remember bit depth, so smaller bit depth, almost little to no dynamic range will clip off to 0. Quantize is probably the least audible thing because it really is talking about the sample rate. Then we have dither. So it adds in noise to the signal in order to reduce the distortion caused by quantization errors. So now ADCQ means A to D conversion, Q size. So quality, or sorry, Q size, quality size, or just the amount of like aliasing on each of the processes. So analog to digital means coming in, digital to analog means going out. So it sounds very similar to a low pass filter. I would say quality, when it's turned up all the way like this, it's supposed to be like very low quality tape player or something like that. But as you might be able to hear, it is spectral. So we can hear those higher frequencies, and when they have that kind of like, I don't know, it's really hard to describe, but it sounds like sine waves progressively coming in and out. That is additive or spectral processing to the frequency range. Okay, so let's get rid of that. Bit crush is really cool. That's probably one of my favorite bit crushers that comes stock with the synth, for real. Flanger, again, really cool, real-time modulation. Okay, so I'm actually going to drop a little filter on the end here. Okay, so again, flanging, we talked about this a bit, but we haven't gone super in depth on how a flanger actually works in processing yet. So how does a flanger work? It modulates the pitch of an incoming signal. You know, with the sine wave like this, kind of like a vibrato effect. Flanging is very similar to chorusing. You know, it's feeding the signal back as well. So there is a modulator on the pitch as well as feeding it back into itself. So how is that different from a chorus? Chorus modulates the feedback onset time, so the delay of that fedback signal, whereas flanging affects the pitch, creating beating or tremolo-like effects. So if you're still confused on that, let me know. We can talk deeply about a flanger. Scroll allows you to change the start position of that modulator. It's the Otto von Sirach filter that, I don't know if anybody knows Otto von Sirach, but every Instagram story he's got that shit on there. That's for damn sure. And it's papayas. Man loves his papayas, man. Otto is a papaya. I think he would really appreciate you saying that. Okay, so now resonator. This is one of my favorite plugs in here. It's a comb filter, but it perfectly combs it into a chord. This brings me to my next point here about what polyphonic effects chains are. So now we have a little poly button at the top, and we also have a solo and mute button. But the polyphonic allows us to play a chord as we are just generating one with this chord thing. And then literally duplicate this resonator for every single note that's being played. Alright, so notice that it's not tuning. That's why I opened up this little note guy here. So we just patch it in here. 100% note. Oof, it's super loud, my bad. Okay, so I'm gonna turn this down a little bit. So, A 440, that's the center pitch. You go and change that A to a different octave to change the octave of our resonator chord. And that's fucking awesome. That's super dope. That's one of the greatest things I've seen come out in a while. I'm just gonna be just like straight up on faceplant stick the whole time. Just because this shit, I don't know if you've heard my music. It's a lot of my shit. I use a lot of resonators like in almost every track. So having this tuned, just like Jesus Christ. I literally tune every resonator in every one of my tracks by hand with automation because Ableton just doesn't have a sidechain to MIDI function for it. Okay, so simple. Intensity, that's how intense the sound's going to be. Or just how much the resonance amplifies the input of the signal. So more input, more resonance. Decay changes the decay of the resonance. And this is the frequency response. So positive and negative frequencies are only negative, which is a square wave. It's going to be a little bit rounder, more like a kind of flute or whatever, or tube-like woodwind. So really cool, really simple. Use it for a lot of stuff as well, including basses. Anything I want. Alright, so those are really the big ones for like this top section here. See, like carve EQ. It's really not too crazy, but we can kind of like, it's kind of like an EQ matching function. That's a good question, Miri. So disperser is a separate plugin for from kilohertz when there's snap-ins. So what disperser does is it actually diffuses and creates like a resonance point around whatever pinch frequency you have. Oh man, I love you. Thanks for the raid 0. Alright, so this is really cool for drums. It's really good for kicks. It's amazing for subs and basses and stuff. So, what it also does is that it creates a little pitch envelope around that point. So, that should be pretty clear on what that does. It creates a little resonance point, modulates it with its own built-in envelope follower. Just to kind of get to your question really quick. Alright, so format filter. This one's really weird. Gives me all these different formats to kind of like randomly... It sounds really good though. Most format filters I've heard from like other places, you know, really scooped. So it's an XY modulator. So that means we need X and Y modulation. Yes, Cam. Pretty much. And that's the way they coded it. So their snap-in plugins pretty much were designed for the multipass. And then they decided to make all that shit part of a synth. And I think it was always the plan. Phase 1, which is their first synth, kind of was prepping, you know, them for creating this really, 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 really good phase modulation engine. And then they combine that with multipass. Because all these snap and kind of like routing functions, like literally the whole functionality of the synth is based on multipass, in my opinion. Maybe it's not, but you know, from glancing at it, looking at it, and using multipass and this, I had multipass first, and definitely became part of my workflow for a lot of things. When I'm just producing, straight up producing, I tend to use Ableton stock more than anything. But when I'm processing and doing other crazy shit, probably go to something else a little bit more crazy like this. Format filter does the formats. You can kind of randomly move around it. It's not really specific. Unfortunately, it sounds good. The reverb actually sounds really good for this. It's not too resonant, kind of like the way Serums is. Serums is just really brittle. Whoa, what did I just do? Did I just pick up this plugin and move it to the other lane and then just do that? Yep, sure did. Yes. So that's the whole to what Stosu just said in the chat. Have you noticed multipass being easier to keep everything in phase when parallel processing? Yes. Specifically because of the low or zero latency of each of these snap-in plugins. So having this really basic UI is like a huge benefit. Having a fancy smancy UI with a bunch of animation on it literally just chokes processing. There's nothing gained by having an animation of a plate reverb. Sorry, Waves. I did not gain any quality from that. I like looking at it though. Got me there. Okay, so this will be in phase, and especially with the multipass, with like doing like ton of distortion and all types of shit, you can get like a ton of really good well, even phase discrepancies. Like I even use that for like sign compression and like all types of like respace sound design stuff. Sign compression is probably the most beneficial for that, just because you can separate each band into its own little thing. You can do 5 bands too, so it's a lot. Yeah, so the reverb sounds pretty good. Again, dampen's going to be the probably, it's like a low pass pretty much. More dampening, more low passing, less dampening, no low pass. Size, decays, diffusion. So, you know, big is going to be like a giant cathedral, small is like a hall, small little room. Width, again, calculates that size. So we're going to go like a full day in reverbs, so you can kind of get an idea of that. We talked about chorusing. So again, delay effects. So it's talking about taps, tap delays. Both affect pitch. One is directly patched into pitch though. Frequency shifter does exactly what it's talking about. Shifts the frequency. Okay, so there's no mix function on that. So how do we go and patch that in? If you want to go and make a respace, you go and send it to 2 places. So 1 and 2. And then I go and send these 2 to the output, or 3. Let's turn that bad boy down. And then drop the frequency shifter. Because there's no mix knob, so we have to do physical mixing. Oh, but that effect is sick. You know, so you can go and change the quality of a sound on another lane, and then mix it in with this frequency shifted sound. Amazing. Really basic function, but gives you a lot more options. Reverser is a chopping and reversing thing. So you can go make like an arpeggio or whatever, chop it up and it reverses it. It's like a delay that reverses the sound. Comb filter, super cool, basic again. Also needs to be note sunk if you want it to be in tune. So click that, click this, drag it all the way up to 100%, and leave it at 440 if you want to be in a key of C3. 220 for C2, 110 for C1. Okay, so the comb filter is not as comby as the rest of, all the comb filters inside of Serum. So it's kind of a trade-off there. That's one thing I find it lacking in, is the comb filtering. Gain is literally a gain knob. So if I wanted to create a feedback loop and create some crazy comb filtering, I could do that. So that's something to think about. Gain, in this sense, what it's used for is just for trim, so you can gain in between sections or gain stage. Ring mod. This is going to be amplitude modulator. What type of modulator are we going to use? We can use sideband, which patches things from here on sideband. Bandpass noise, low pass noise. They are noise being bandpassed. So it can be kind of like a Geiger counter if you're looking for that kind of sound. So self-modulation, not as prevalent. You can add different effects before and after in order to get a little bit more coloration out of it. Sine oscillator, though, is probably the most effective. So a lot of stuff to do there. Bias changes the amplitude, so where that zero crossing is going to be, 0 allows it to be perfect. Rectify, I think we talked about this. Rectify should give it all positive values. The reverse rectification, you got all negative values. Okay. So that's cool. All right, so ton of effects in here. We're going to talk about some more of these next week. I want to talk about a couple more before we kind of like break off here, because it's a lot to digest over the week. Just talking about signal flow, modulation, sending it into patching here. So we talked about disperser. It's one I did want to kind of like talk about. Haas effect is really cool when mixing between left and right channels. So it's literally a spreading function. That's really cool for using as a regular plugin as well. Yeah, so I would definitely recommend trying out a lot of this stuff. Limiter, dynamics, compressor, gate. These are all going to be dynamics plugins. So gate is literally going to show you a gate. So this is where it's going to cut off sound. And then trance gate is going to be a syncopated gate. All right, so that's cool. Just neatly chops up your sound into a nice trance rhythm. Another couple ones I want to talk about. We have a multipass, so we can patch in, you know, stuff from here and patch in other types of multipass effects. So that's cool. We're gonna talk about the multipass in a different class. So there's a lot of stuff to talk about, just in terms of like everything in depth. Some of this stuff should be very self-explanatory, like tape stop. Sick. So I recommend just going in and trying out all these effects from just twisting knobs and doing your thing with them. But I kind of focused on the ones that I feel personally are really, really effective. We're going to talk more about like the actual mixing plugins a little bit more next class here. But also some of this stuff should be still a little bit over your head if you don't really understand how a compressor works. So we're going to have to kind of step back into that. Ensemble is one of the coolest ones, in my opinion, as well, just for chorusing effects. So all these little guys floating around in here are delays. I just really love this animation. Super good. Also, the modulators that are on this for the motion. This is all stuff we're going to be doing in oscilloscope art class, if you want to go to that. So these are actual like vector mapped points and all that stuff, and you can draw all this stuff with it and add modulators in the form of waveforms that create all these different shapes by default. So like if you put a sine wave into it, it'll literally create a circle. Put a square wave, it'll look like a square. It takes on the shape of its own waveform input. It's really cool. So yeah, if you send random stuff into that, it adds modulation on top of it. So if you wanted to create a circle shape, like the shape of a sun, and you can put like an animation or anything else that gets dispersed, I guess, and generated by that, you can have the sine wave be the carrier. So it's like the visualizer looks like a circle. And then when input comes in, the circle expands. So it's actually an FM oscillator that's taking in the audio input from whatever audio you're using just for your visualize. It's really cool. I find that stuff fun. Okay, so that's about it here. Another one I use a lot is the Faturator. That one, it's just like, I usually put this on like lane 3 if I'm going to sum everything together. It's really heavy, it's really fuzzy. Color set to 0 is off. When you turn it up, it turns on a low pass. Stereo turbo allows you to get a little bit more definition out of, I guess, left and right channel. It's like a basic cause effect. All right, so that is going to do it for the intro into Faceplant. So we talked about how to load up generators, how the lanes work, how modulators work, and how the voice engine works. So your homework is to make 3 patches from scratch inside of FacePlant. And you can definitely submit that whenever you have time, and you don't have to submit it at all. I will just judge you silently from the comfort of my own home. But for real though. Okay, so I'm gonna make a little patch now. I'm just gonna make like a base, something I'd actually use. I'm gonna save this patch too. Okay, so I'm gonna make something wonky, just to kind of finish off the class here. You know, I literally covered everything I wanted to talk about today, which is wavetable selector. We didn't go too deep into the wavetable as I wanted, and we are ending pretty close to 9 here, which is good. So yeah, if you have any, like, again, lost a little bit on today, come back to this, read through it. It'll cover pretty much everything I just talked about, and I specifically only pulled out the pieces that I was going to talk about today. So I didn't give any extra information that I wasn't going to cover, including the LFO editor. I was actually not going to cover this, but I figured since we're talking about modulation today, might as well. But yeah, if you need another reference, again, come back to this. It has all the things in here. And I got the nice little numbered out diagrams. Okay, so again, check out the manual. And then check out this, the Casio CZ101, because we're going to be talking about phase modulation next week, pretty much, and getting more crazy technical in FacePlant and making some really wonky shit, not like just some basic chords and explain the UI. It's going to be way more in depth than that, just because that's not really how I use the synth. Alright, so I'm going to take off that. Alright, so I want to make a bass. Alright, so that's going to be my main oscillator here. I'm going to right click, group, create another group. It's going to be a parallel oscillator. What do I want to do? I think I'm going to make this a wavetable. Yeah, make it a wavetable. And then we're going to get another group going on, because I want to get 2 parallel oscillators and then 1 mod oscillator. And then I'm actually going to get a sub oscillator too. So I guess 4 groups. So this one's going to be our sub. Sub. Mark that out. And then 1 more for mod. What's great about your mod oscillator group is you actually don't need to patch anything from those synths. You can literally just take that output and really patch it in hard. Yeah, that Wikipedia article is actually really good. That's why I included it in there, because the CZ101 is actually a very unique synth. It's actually, phase modulation synthesis is one of those overlooked types of synthesis just in general. So it's very underused, and so they brought it back in a really strong way. The creator of Reactor also believed that phase modulation synthesis was really the future. So did Don Blucla. So it's a lot of people from the high-end, you know, history of synthesis, synth gods, you know, they believed in phase modulation synthesis more so than FM. And the first synth that was created for Reactor on Reactor 1 and Core, which was Core with a K, was I believe the phase 1 as well. So they kind of copied that a little bit, but I appreciate them for that. Okay, so these guys, okay, actually I'm going to delete this. I'm going to add an output here. Then I'm going to route both of these into lane 1. We're going to sum those. Yeah, we're going to sum those. And then I'm going to add a filter just so I can kind of control the signal a little bit. I'm just going to open it up all the way. Add 2 filters in here. And then just to kind of like wrangle everything in, oscillator 1, just close that. So what I do whenever I start making patches like this, where I'm actually like going pretty deep, now I have 4 groups, I have all my oscillators set up, you know, like I save the patch once it's done, you know, and then I keep on building from that same patch, and I build, you know, maybe 10 patches from one patch, and they might be, you know, Donkey Punch 1, and then there's Donkey Punch 1 through 7, you know. Alright, so I'm going to sum these to LFO, or lane 1, and then I'm going to patch my sub to the output for now. So again, we need an output patch, so we set that, master, done. Cool. Turn on the gain on that for a minute. And I'm going to turn the gain down on my first oscillator. We're going to start on number 1 or 2 here. I'm going to make a respace. Obviously, who do you think you're dealing with? Of course I'm going to do respace. Alright, so I'm going to pitch this up, and I want to do this in the harmonic series, so let's go up 1 octave for now. So I got 2 oscillators. Maybe this one's going to go up 2 octaves. And that's going to be a wavetable. Let's make it let's not make it a saw. Let's make it a growl. Gross. Okay, so I'm going to patch this guy, this gross one. Actually, no, let's start with the sawtooth, because I'm using a sawtooth right now on this oscillator. So remember to patch this, let's push this, scroll up. My scroll is working a little bit weird right now just because I'm streaming pretty hard right now. Cool. Alright, so it's sounding heavy already. So I'm going to stop there for now. I'm going to add this in. Turn this down a little bit. Hey. No clue what you said. Cannot open it. Alright, so I want to get it to sound a little bit harmonic and kind of detune with the other one. So I do have modulation on analog phase and wavetable phase. God, this is super heavy already. Alright, so I'm going to limit this a little bit. Just going to do a little bit of modulation. The phase can have a little modulation. So now I can go and add a little extra auxiliary modulation here. Alright, later Stosu. Lord, that is a heavy one. Alright, so you know, now I can like go and split this out to a couple different places here. And I'm really only doing a couple things. I see all that modulation happening in real time too. That's super awesome. You know, maybe I want to switch this up a little bit, switch the ramp to up or down. So again, I'm auxiliary modulating how my FM is being injected, or PM is being injected into my sound right now. We're going to talk about auxiliary modulation next week. Really simple. Just hit the little plus button, or the little star button. We already talked about auxiliary modulation in Serum as well. Okay, so we can also do like actual amplitude modulation as well. What's my tempo? Let's go 4. So I'm going to patch that into the out. Okay, so we're making a deep one. Alright, so this is, again, not being mixed with the sub, so I can do a lot to this. With some type of like space or something. Oops, didn't patch this one in. Let's do that. So I have modulation going on the sub. Maybe I want to make this like do a little quiver, little baby wobbler. Yeah, so that sounds super good. I'm really stoked on that sound. I'm gonna save that. I'm gonna call this Darth Wub. No, I just deleted it. Never mind. I will not be saving it. I accidentally hit the new button. Anyways, that's fine. I do it all the time. But also, whenever I'm like looking for a sound, I usually don't go to a preset personally. I usually just load up a sound in live. It wasn't meant to be. It's all good, but I really like the sound. I'm gonna miss it. It's gone. That means none of you can have it either. Okay, so that's it for me today. Hope you guys learned some shit. Also, let me know if you have any questions about Faceplant, anything we went over today, any questions about the curriculum or the lesson plan here as well. If you're confused in some of the wording inside of their manual or anything like that, just hit me up. Also, if you have questions about the previous material and where we've been or where we're going next, hit me up as well. All right, so that's going to be it for me today. I'm going to play some sound design. Alright. Let's do Chumpo. Bye.